Okay, thank you very much. Appreciate this opportunity and would like to thank the organizers for having asked me to chair this important session on dynamic assessment of the impact of climate change on ecosystems in different agroecological zones. I think it's a very relevant and very important subject to be deliberated. And the first keynote speaker for this particular presentation is none other than most famous scientist in India on climate change, Dr. Himanshu Pathak. Dr. Himanshu Pathak has recently taken over. Right. So Dr. Himanshu Pathak is the Director General of Indian Council of Agriculture Research and Secretary, Department of Agriculture Research and Education, Government of India. He had been earlier the director of a famous institute, which is known as National Institute of Abiotic Stress Management. He is an expert in climate science and also basically a soil scientist. He had been director of the Rice Research Institute as well, and he was the lead author of the IPCC Fifth Assessment Report in 2014 and refinement to the IPCC guidelines for national greenhouse gas inventory in 2019 and reviewer of the IPCC Sixth Assessment Report, which was prepared recently in 2022. He is recipient of many national awards and well-known expert in modeling for prediction of impact of climate change. So we can't find a better person to give this lead presentation to begin with this particular session. Dr. Himanshu Pathak, welcome, and floor is yours.
Thank you very much, sir. Professor Belchagi, thank you very much for kindly giving me this opportunity to make a presentation, and of course, Dr. Poroda for inviting me to make this lead presentation. I shall share the presentation now, whether my slides are visible.
Yeah, they are.
And am I audible clearly?
Yes. Yes.
So, thank you very much. Colleagues, I'll be presenting on simulating the impacts of climate change on the crop and soil processes. As we all know that the climate is the major driver of crop, soil, animal, as well as human health. Whether it is solar radiation, air, water, soil, and we have been discussing yesterday and today, all of these drive the plant processes, crop production, forestry, fishery, animal, and of course, finally, human health. So these are the major drivers. And all these drivers affect plant and soil processes. In the plant processes, which are affected by climate, is photosynthesis, respiration, water relations, nutrient uptake, phenology. Among the soil processes, the most affected processes include water availability, nutrient availability, root growth, biodiversity, as well as greenhouse gas emissions, and microbial processes, which mobilize the nutrients, nitrogen, phosphorus, potassium, and so on, and also emission of greenhouse gases. So all of these processes, be it of plant, soil, as well as microbial, are affected. It is widespread and it is intensifying. We are going to cross around 1.5 degrees centigrade line by 2040. Rainfall variability as well as intensity is increasing all over the world. Sea level rising. Cyclones are becoming fiercer and more frequent. And the projections are that all the extreme events of climate, whether it is cyclone, heavy rain, heat wave, flood, drought, all are going to intensify and going to be more and more frequent. Now, how to simulate and how to understand and how to analyze all of this? We all know that the yield, crop yield of any crop is the integration of several abiotic as well as biotic factors. Factors include cultivar, weather, soil, water, agronomy, pest, pollution, inputs, and so on. So all of these affect and finally integrated and expressed as crop yield. Now, it is really very, very difficult for any ordinary human being to experiment and evaluate the impacts of each of these factors. And of course, it is more difficult to integrate their combined effects. It is really very difficult to experiment and also to evaluate. But then simulation models, using the helps of modern information and communication tools and mathematical approaches, we can really achieve those. We can really integrate. We can make some decisions with multiple goals, and we can also resolve the conflicts when there is conflict of interest, when there is conflict in terms of which particular economic sector to be promoted or not promoted. All of these things can be done, can be evaluated, can be assessed using some simulation models. And not only up to crop, even we can also assess the farming system, which has got components of crop, livestock, fisheries, all other things also can be combined, and with latest information and communication tools, using some of the simulation models, we are in a position to assess the impacts of climate change or any other input on the whole farming system. But of course, if we want to do some simple calculation, like what is going to be the potential yield, say cultivar and weather, then the requirement of the information is very, very small. But then as we go and try to include more and more drivers, more and more inputs, more and more factors, then certainly we also need to have more and more information. For example, if you want to calculate only water limited yield, so it is going to be cultivar, weather, and water. But then if you want to also include nutrient dynamics, waste component, economics, then of course we need to have information of cultivar, weather, water, nutrient, pest, and of course economics. So this becomes really more information driven. But once you have got all those information and if you have identified a suitable model, then of course you will be able to calculate or simulate what is the current position, how much is going to be the current yield with the available inputs. And then of course you can also calculate how much is going to be the future yield with the changing climate, with the changing management. And then again the simulation model will help you to calculate if you are going to adopt one intervention, adaptation option or mitigation option, then what is going to be the benefit of that particular option on crop yield, on soil fertility, on water saving, and so on. So simulation models really give us all these avenues of opportunities to evaluate, to assess, and then help us in taking a better and informed decision. Now there are various levels of modeling. It could be a simple calculation if you want to have some very quick and easy information way out. It could be some empirical equations. It could be semi-mechanistic model. Mechanistic model means when those mathematical equations simulate the mechanism underlying in a particular process. Then of course there could be fully mechanistic model. And then of course now we can also use artificial intelligence, machine learning, and all of these new things which can give us more and more information. So depending upon your requirement and depending upon the complexity of the system, you can decide which kind of model you are going to use. But of course, certainly we prefer that if you have got information and if you really want to know the details of it, mechanistic models or semi-mechanistic models are the one at this point of time. And of course, when artificial intelligence develops a little bit more, we'll be able to use artificial intelligence as well. Colleagues, you will be very happy to know there are already several simulation models are being used by researchers all over the world. And probably you know some of those names. Those are CIRES, Century, IDDC, NTRM, and so on. And we have also developed one or two of our models, which are also being used almost widely all over the world, is called InfoCrop model, which we published in 2006. And also we have got a semi-mechanistic model called InfoRCT. And then of course there are several other models, including EPSIM, which can help us for farming system assessment. Before I proceed, let me tell you, the beauty of these models these are having modular component. That means if you want to calculate only one component, and if you do not want to calculate the other components of the whole system, so there is a provision of switch on and switch off. For example, if somebody wants to calculate only soil water balance, then he or she can switch off all other components like pest dynamics, nitrogen balance, carbon balance, assuming that all of these things are in optima. Only water is the limiting factor. So you can switch on only the soil water balance component, then you can calculate what is going to be the effect of water on crop growth and yield processes. But then, of course, if you want to calculate the impact of all of these things, soil water, soil carbon, soil nitrogen, pest dynamics, and so on, then of course you have got the provision of switching on all of these modules, all of these components, and you are going to get a complete information. But colleagues, you also know that to run a model, we need data. Some of the models are very, very data hungry, and as I said in the beginning, if you want to have more and more detailed information, you also need more and more data to be provided to the model. But some of the minimum data which are required for running any crop simulation model, those include daily weather data like maximum temperature, minimum temperature, rainfall, and solar radiation, soil profile data, soil organic carbon, and so on. Then, of course, agronomic management and cultivar characteristics. So weather, soil, and management and cultivar, these four are the minimum data which we say are required to run any crop simulation models. Without all of these things, probably you will not be able to calculate the actual yield and so on. But of course, using these models, you can then extrapolate and integrate several other dimensions, including spatial as well as temporal distribution of climate, spatial distribution of soils, crop and livestock simulation models could be included. And then, of course, you can also put production technologies, new interventions, and then you will be able to calculate what is going to be the spatial yield distribution, what are the management impacts, and what kind of management you can go for to reduce those kinds of adverse impacts. So these are all the potentials of simulation models. I shall just give you a few examples of how simulation models are being used for assessing the impacts of climate change in some parts of the world. All of us are very familiar with these IPCC projections. What is going to be projected temperature in 2040, 2060, 2100, and so on. Let me tell you, all of these numbers have come by using some kind of simulation models. And so therefore, IPCC very extensively uses these models. Then also, what is going to be the frequency and intensity of extreme events in the changing climate, whether it is in terms of temperature, precipitation, agricultural drought, and so on. All these things are also calculated using some kind of simulation models. In India, we are using these simulation models quite extensively for last around 25 years or so. So these are some of our estimates using the models. We calculated what is going to be the impact of climate change on crop yield. So we estimated that the wheat yield is going to be reduced by around 9%, rice yield by around 12%. Then, of course, the area of rice, rain-fed rice particularly, is going to decline by around 15 to 40% by 2015. Grain protein content also could be reduced. Micronutrient content also will be reduced. So some of these are just examples of how we are using simulation models to calculate the impact of climate change on crop yield as well as quality of crops. Not only in our country, but all over the globe, several estimations have been made. For example, this is one example which has been done by CIMMYT about hotspots of climate change and food security kind of thing. So again, you can see which country is going to be affected by how much because of changing climate. Not only in terms of crop yield, but also what is going to be the impact of climate change on farmers' income or farm profit. So, for example, the left-hand side shows you that this is the baseline one, greener one. Then, of course, in 2040, what is going to happen if we follow the business as usual scenarios? So, what it says that currently, if you are not following any adaptation options, then 17% reduction in profit currently. But then, if you follow again business as usual scenario, then by 2040, this reduction, which is currently 17% only, is going to increase up to 29%. And 20% reduction is going to be there in plant available water. And my previous speaker was extensively talking about water, which is so important for agriculture and, of course, human society. But of course, our study also shows, and I shall talk a little bit more about it, that this reduction of profit can be compensated by implementing some of the adaptation measures. This is another example for rice yield, wheat yield, and net farm income for 2050. You can see it is going to be reduced by 12% for rice, 24% for wheat, and net farm return is going to be reduced by around 14%. And these are the numbers about vulnerability to climate change and how many percent of farmers are going to be affected by the adverse change in climate. Colleagues, you also know very well that this climate is changing because of emission of greenhouse gases. And agriculture is one of the major contributors of greenhouse gases, contributing around 10 to 12% directly. And if we include the deforestation part and other land use part, then the contribution goes up to 25%. So 1/4 of the emission of the greenhouse gases come directly or indirectly from agriculture. Of course, we know that different crops, the emissions of greenhouse gases are different. If you are growing lowland rice, then the emission is quite high, followed by sugarcane, potato, wheat, and so on. Using simulation models again, we also calculated how much is going to be the emission in different crops in different districts as well as agroclimatic zones of the country. So these are just some of the examples for India, and similar examples can be obtained for many other countries. And you also know that submission of this greenhouse gas emission inventory to the United Nations is obligatory for the signatories. And in the Tier 3 methodology approach, every country is required to use some kind of simulation models. Most of the countries currently are using Tier 1 method, using the default values of IPCC. Some of the countries have moved to Tier 2 method, where they are using the indigenously developed coefficients of emission, and only a few countries are using simulation models for assessing emission of greenhouse gases. But in times to come, all the countries have to adopt the simulation models for estimating emission of greenhouse gases. Not only emission of greenhouse gases, but soil carbon is also very, very drastically affected because of climate change, mainly because of increase in temperature and also because of heavy precipitation causing erosion and so on. Again, the simulation study shows that the soil organic carbon content, which is already low in most of the developing countries located in the tropics, this is going to be further reduced in times to come. And this is going to have a very severe impact on soil health and also the crop productivity. These are just, I tried to give some of the examples of how simulation models are being used to assess the impacts of climate change on soil, on crop, and farming system processes. Now, how to manage the risk of climate change in agriculture? And again, we can use simulation models to identify which management option is going to have more benefit and which intervention is not going to have that. Colleagues, we generally say that there are mostly 5 steps in managing climatic risk, and I call them farm building approach. Those include foresee the stress, forecasting, adapt the stress, adapting, respond to the stress, responding, mitigate the stress, mitigating, and finally build capacity to manage the stress. So FARMB. So farm building are the key steps for managing climatic risk. Now, simulation model, particularly semi-mechanistic or mechanistic models, can really help us in all these 5 steps and in managing climatic risk. I shall just give you 1 or 2 examples and then I shall conclude. Colleagues, you know that there are several adaptation options, and these are some of the list, and this figure also shows what is the current level of adoption of the adaptation option. So you can see some of the options are adopted very, very meagerly, but some of the options like water management, like agroforestry, stress tolerant and high yielding breeds of crops, these are some of the options which are adopted quite widely, and farmers are getting benefit out of it. But just to summarize all of these things, we did a study here. What we saw is that, for example, in wheat, if you follow adaptation, the blue ones, then the yield is going to be more. And not only in the case of wheat, but similar example you can get for rice, for maize, and also for any crop. If you do not follow any adaptation options, the blue lines in all the cases, then the crop yield is going to be reduced. That is going to be this orange band. So orange bands are always lower than the blue one. That means adaptation benefit is there in all the crops in almost everywhere in the world. We did one detailed study to calculate how much is going to be adaptation gain, and we observed that there could be big gains due to adaptation. And these are some of the numbers which we showed for some of the crops like rice, wheat, maize, and so on. In summary, for adaptation gains, in Indian agriculture, what we observe that if we do not adopt any of those adaptation technologies, then the crop yield is going to be reduced by around 20%. But if we go on adopting at least 1, 2, or 3 of these options, for example, stress-tolerant cultivars, adjusting planting date, optimizing irrigation, optimizing fertilizer use, conservation agriculture, integrated nutrient management, and additional inputs, then not only we will be able to compensate the loss, which is currently estimated as around 20%, we will be able to even increase the total production. So this is the benefit of adaptation. But of course, if you have to adopt, then farmers have to incur some of the cost, and that probably sometimes it may not be feasible for small and marginal farmers to incur some of those costs. So probably state has to come inside. The models also can give you a fairly good idea about eco-regional crop planning, that which crop should be planted or grown in which part of your country. Because crops requirement is different. For example, rice requires more of water. So you should be growing rice in the areas where there is more of rainfall, where the soil is less percolating, and where the temperature is also congenial. So using some of the models, we also calculated, for example, in India, which parts of our country are more suitable for growing rice, which parts are not so suitable. And if you want to grow rice in the not suitable area, then certainly you have to provide more and more irrigation, more and more inputs, and so on. So models really help in taking a good decision and can give you an option for climate-friendly farming without emitting more of greenhouse gases and without costing too much. It can also give you a fairly good idea that if you want to diversify the crop, then which crops are going to be more suitable for diversification. Here is an example that if you want to diverse from rice to some other crops, then what is going to be your opportunities and what are going to be the cost for those diversification, as well as what are going to be gains of those diversification. Colleagues, you also know that crop insurance is one of the very important options, not only in the scenario of climate change, but also climatic variability and climatic aberrations. And at present, more than 104 countries are using some kind of insurance system. But what we observe that if we can use some of these models, like for example, one is crop loss assessment monitor, CAM, then your estimation of crop loss and then the compensation which you are going to give to the farmers are going to be more precise, more accurate, and that is going to help not only the farmers, but also the insurers, also the government of the country. So these are some of the very good examples of how models can be used. Similarly, information and communication tools and weather-based agro-advisories for early warning system kind of thing are also very, very useful for climate change management. And again, there is a very big role of some of the simulation models to be used for there. But before I conclude, let me also tell you, there are some concerns about maladaptation of a particular intervention. If you somehow do not follow the given package of practices, and if you go for maladaptation, then sometimes, in spite of the good technology, the loss would be even more. For example, this is in our intensification things. In the current climate, of course, if you follow, then the benefit is going to be more. But in the future climate, you can see the lower part is having more number of dots. That means more possibilities of getting lower and lower benefit. And that is true even for climate smart agricultural practices. In the future climate, the effect of a particular technology or intervention is going to be more and more uncertain, more and more risky. So therefore, in times to come, we have to be very, 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 very concerned and judicious about selecting a particular technology, selecting a particular intervention, and then what the benefit we are going to get. We also talk about changing lifestyle, changing diet, and there is very good correlation of your diet and emission of greenhouse gases. Sometimes back we did this kind of study that which kind of diet is going to emit how much amount of greenhouse gas. And you can see if you are a vegetarian, then of course the emission is less. If you are going to be non-vegetarian, particularly mutton, then the emission is going to be more. Now, similar kind of studies have also been done for other countries of the world. And you can see in the lower figure how the emission of different countries are and how the emissions are going to be changed if we change the lifestyle or our diet. Before I go to my concluding slide in the next one, let me tell you that simulation models are really very useful tool, but then simulation models have also got some of the limitations. The limitations include that it is always difficult to mathematize all the biological processes because of our incomplete understanding and because of the complexity of the biological processes. Secondly, incomplete understanding of plants, environment, and management interactions sometimes becomes handicapped to develop and use a simulation model. Now, developing a crop or animal model is difficult, as I mentioned, and there are limited number of models available for all crops. Most of the models have got few crops, not all the crops which are grown globally. Therefore, we need to have calibration and validation in different agroclimatic zones, which is a prerequisite. And again, idea from that knowledge is the main limiting factor. Therefore, for using or developing a model, we always need team effort. Individually, it is difficult to either develop or use simulation models. You always need a team of crop scientists, team of soil scientists, team of climate scientists, team of social scientists, and so on, and then only you are going to be successful. Therefore, Chairman Sir and colleagues, let me conclude saying that the models are holistic, universal, knowledge-based tools for global as well as local applications. These are potential tools for assessing the climate change impacts and adaptation gains, and I gave some of the examples. However, we need quality data for calibration and validation, and for building evidence, learning, and scaling up the adaptation options. It is always difficult to capture all the complexities of biological systems, and knowledge is limitation, but of course, a lot of research is going on, a lot of developments are happening in every areas of research, and therefore, probably in times to come, we will be able to become more and more accurate, more and more precise in our modeling approach to come out with more sensible results. But as of current, still, as I said, there are several limitations. So we need to use the simulation models with caution, and whatever result we get, we should interpret the result judiciously. So with these few comments, I once again thank each and every one of you for giving me this opportunity to share some of our research and some of our thoughts about using simulation models for assessing the impacts of climate change on crop, soil, and farm income. Thank you very much, Chairman Sir, and all the distinguished colleagues.
Thank you, Dr. Excellent presentation, summarizing all aspects which we expected from your keynote presentation. You have definitely also indicated how to use them more judiciously and how to take advantage in our farming systems approach ecosystem wise, and also your emphasis on adaptation and scaling of conservation agriculture, in fact, should draw great attention and maybe form major recommendations for COP27, because time is ripe to move forward. There are models, we need to use them. We use them with a better understanding, and also help the farmers for their environmental services, especially like crop insurance you mentioned, and it has been used in India quite effectively, the modeling for crop insurance when there are, adverse impacts of climate. So maybe we can take one or two quick questions if you are available.
Yes, sir. Yes, sir. I'm there. I'm available, sir.
maybe 5 minutes we'd like to spend
Sure,
because it's a keynote presentation.
Sure, sir.
Maybe Dr. Adil, you are in the house, could assess whether there is any question there.
Yes, I think it's, thank you for the presentation. It's wonderful presentation, but your conclusion was that we need, if you can write a very precise recommendation, we can include it in our final report. And if you can send it to us, I will appreciate this. Thank you.
We can request Dr. Himanshu to give 4 or 5 key points. I will also discuss with him,
Sure, sir.
which can be considered for you to include in the recommendations.
Thank you.
Thank you. Any other point? If not,
Yep. Okay.
because it's a very interesting topic, often people have been raising concerns whether modeling is helpful, and whatever has been projected today clearly tells that we are in a position to understand what would be the impact if there is no action. So action is needed and time is running out, and I think there is urgency. So maybe there is no question, Himanshu. We would like to thank you.
Thank you. Thank you very much.
Request all the participants to give him a big hand, please.